This PowerPoint is going to focus on weather fronts and looking at weather entirely. But first, a quick recap of the air pressure. So a couple things that we identified last time that we spoke was air moves from high to low pressure centers. Air moves inwards towards the low pressure system in a counterclockwise motion. Air rises above a low, and the opposite is true for high pressure. We call the movement of air wind, right? So let's not forget that when we talk about air moving from the high to the low pressure, talk about a wind. And the greater the difference in atmospheric pressure from one place to another, the greater the pressure gradient, and therefore the stronger the wind. It is convection currents that are causing the circulation of air, the rising of air above the low, and the cooling at the high. All right, so we're going to look at weather. We've looked at pressure. We're going to add in fronts to those pressure systems. So not looking at the fronts yet, but here again, just as a reminder, we have the ISO bars on there, and we have a high and low in this map. And the question is about the difference between the high and the low. And so our high is 1024, our low is 992. And so the difference between those numbers would be B, 32, right? All right, so there's a variety of different websites that you can go to look at this movement of air or wind, these wind maps. This one is just drag this over, has a lot of historical images at the bottom of the gallery, but also a look at the current weather, albeit just for the United States. There are, on the next page of the PowerPoint, some other links that will show a more global view. And so here we have the United States, and we have this circulation that we can see right here. I'll pull up the map for today that we're going to look at in a little bit, and that's because there's a low right there. And so we can actually see that air movement counterclockwise around the center of these lows. There's another one up here, and this is the one here right off the coast of the United States of Canada. And so we can see the air spiraling around counterclockwise inwards towards the center of the low. All right, so each of these websites shows these wind maps in a slightly different way. Got 3 of them there. You can take a look at those. All right, so how do we know where the wind is and what's going on? I kind of alluded to this in the last presentation. We use weather station models. And so all this information about weather is collected at a variety of sites across the country, and we put together what you see here, this weather station model. A couple of important things about the weather station model is the location of a lot of this information has to be exactly where it is shown on this picture. There is 1 or 2 exceptions to that. We're not going to use all the elements that you see here for the weather station model. We are, if I can get my slide to advance, we're going to look at just what's on this sort of abbreviated weather station model picture here. So I think the best place to start is the circle. So normally when you look on a map, it'll have the town location and a circle there. Usually that circle indicates the population. So let's just say it's Towson. On the map there would be a circle for Towson, and we would put the circle as our starting point. So basically we're going to shade in the amount of cloud cover, as you can see here. 75% of the sky is covered with clouds, and so 75% of the circle is shaded in. If there were no clouds in the sky, then we would just leave it completely white, not shaded in at all. All right, so that's where I like to start, with the circle, and then shade in the amount of cloud cover, if there is any. And then the second thing I like to put in is the wind. All right, and so this is showing the wind out of the southeast. Right, so the wind is blowing to the northwest. So just imagine that there's a little arrow at the end of this. It's pointing towards the town. So the air is moving from the southeast to the northwest. Right, so that's how we read this. So winds out of the southeast. That's this line here showing the direction. And then at the end, we have these little sort of fairings at the end, and those show the speed. We're going to do a very abbreviated version of that as well, and you can see that illustrated here. So one full length is going to be 10, and 1/2 is going to be 5. Okay? That may raise the question, well, what if there's only one on there? We won't know the length to compare. We won't know if it's a 10 or a 5. So we come in a little bit from the end and put a little fairing in there. That says that it's less than 10. All right, so that's on the next slide or the one after that. So we'll come back to that in a second. So once you've got those 3 pieces of information, you've got the cloud cover, you've got the direction that the wind is coming from, and you've got the wind speed, then you can go in and put the rest of this information in. And the reason is that this is going to be as close to this position as possible is where you're going to find the barometric pressure. Okay, so you might have to adjust it a little bit if your wind is coming from that direction and you have to put that line through there. Then you can shift the barometric pressure a little bit, but it should be in sort of the upper right quadrant of the circle. All right. Again, a reminder to what we said, very important, we only use the last 3 numbers, so that is 893, which is actually read 989.3. Right. Again, there is no 1089.3 that we're going to see realistically in the weather conditions. So we know that it's 989.3. All right, and then temperature here is always to the upper left of the circle, this sort of quadrant here. Again, it's going to shift a little bit if your wind direction is through there, but temperature to the upper left, 64. Sometimes you'll see the numbers in Celsius, sometimes in Fahrenheit. We're not going to worry too much about that. It might go back and forth between the two. And then the last thing that we will worry about is the symbol here for the weather condition. There's some common ones that we're going to come across. I don't need you to commit them all to memory, but drizzle is this comma symbol here. You can see some other ones. Again, by no means do I want you to commit them all to memory, but there's some common ones that you'll see. Rain, this looks like a dot. Showers, upside down triangle. Sometimes you'll see fog listed there. Thunderstorms are pretty common. See that kind of symbol there that just kind of alludes to a thunderstorm. Snow is pretty common. Here's the wind symbol. Again, we're kind of abbreviating this, and we're going to say that this is kind of like a 10, and this is less than 10, and that's about 15, and that's about 20 and 25. Again, it's not exact, but keep in mind that the wind speed is not consistent. It changes over time anyhow. So if you're having trouble with it being off and not exactly precise, wind is never precise. It's never blowing steadily at 25 miles an hour for the entire day. You can see again here with cloud cover, same thing. There's some different symbols. We're going to stick the shading in, about the percentage. Again, that varies, and it's hard to determine how much of the sky is actually covered with clouds. So that's good enough for us. 100%, sort of 75%, 50%, 25%, 0. We'll stick with those. All right, and so here you see a weather station model map, a map of the United States with various weather stations. You can see some of the information is missing here. We don't have the precipitation type here, but we do have atmospheric pressure, we have the temperature, and we have this other symbol that we're not going to worry about the other number there. All right, so what do we do with all that? Well, we try to look for patterns in it and make the maps that you would more likely see on sites like weather.com and places like that, the Weather Channel. So before we do that, let's practice making some weather station models. And so there's 2 pages in the investigation manual. The first one, page 66, I've given you the weather station model and asked you to write on the left side the various information. And then on page 67, it's the opposite. I've given you the information and I'm asking you to draw the weather station model. So pause for a moment, go back through. If you need to go back through the PowerPoint slides, it's up on Blackboard. You can use those slides to go through and practice that. So pause right now, go through those stations, make some maps or figure out where the information is, and then we'll pick up there in a minute. All right, so at this point, hopefully you've practiced some weather station models. This website here, you can go and look at some additional weather data and practice making models based on that weather data. But I really wouldn't go forward until you have weather station models down, both looking at them and automatically kind of in your brain being able to read what the various things are telling you before we go on to look at maps more holistically. All right, so moving forward, we want to be able to look at those maps, identify where the lowest pressure is, put an L there for low, and then start to draw circles around the low, showing where the areas of atmospheric pressure are the same. We're drawing those isobars in. That can get a little bit tricky in practice, and it's best done in pencil, and sometimes people have a difficulty doing that. Again, we can do the same thing with temperature, right? We can connect all the areas of equal temperature and draw isotherms. All right, so I guess a little aside, and then we'll come back and look at maps. So again, looking at air pressure, we can determine a lot of things. We can look at the center of the high and low, and from that we can start to see where the weather fronts fit in. And so to do that, I think we first need to talk about what a front is. So there are these air masses that you may have heard about in the past in other classes. I'm not going to ask you to necessarily commit them all to memory, but some are warm air masses and some are cold air masses, and they're moving from either from the poles down or from the tropics up, right? And so they're listed as, you can see their names there. Sometimes they have names like polar, they're bringing that cold air down, or tropical, bringing that warm air up. And so these move across the United States, and again, we're focusing on the United States here, and they collide, right? And so these air masses meet at a boundary, which is called really a front. It's where two of these air masses collide. So the two main fronts that we're going to look at are cold fronts and warm fronts. There are other fronts listed here, stationary fronts, occluded fronts, all important, but we're going to focus on the cold fronts and warm fronts. I think in terms of what we can teach to secondary students, this is a good place to start. I think there's a lot that we can do with cold fronts and warm fronts, especially given the region that we live in and the prevalence of this pattern that comes through our area. All right, so these fronts are really sort of combining and moving across as the country as the globe spins around. During different times of the year, more cold air is being pushed down from the north, or more warm air is coming up from the south, and you can see that that shifts this jet stream. But the general trend is that weather moves across our country from the west coast to the east coast. Now, one of the first people to notice this was actually Benjamin Franklin. In addition to all the other things that you know about Benjamin Franklin, in his job as postmaster in Boston, he communicated with other postmasters in other areas of the United States. And he did what a lot of people do when they talk to people in other areas of the United States. They talked about the weather. And he started to notice this pattern when he would talk to people to the west, that a few days after they would talk about the kind of weather that they experienced, he would start to see that shift through and move through Boston. So he started to piece together this ability to sort of predict the weather in Boston based on what he was hearing happening in other parts of the country. And that's really what we want to be able to do, is to predict weather a few days out, maybe 2 days, 3 days out. Anything more than that, our accuracy is probably going to go down and not be a worthwhile prediction. So I think we can do that with the information that we have, and I think that your students can do that as well. All right. So this picture is going to be really important because it's one of the common features that we have. Okay, so we have a high pressure system and a low pressure system. Generally speaking, the high pressure means pretty fair conditions. The low means, less than ideal conditions. When it comes to warm fronts and cold fronts, we're going to be focused on the low, and we see that here. We see the cold front in blue with these triangles. A student once said that they remember that because it's frostbite and cold conditions, and those look like jagged teeth. And these little half suns reminded the student of warm weather. And so you can see, if it's in black and white, the color's not going to help you, but here it's in red for warm, blue for cold. The half circles are indicative of warm front. Remember that the air is moving counterclockwise around the low, and so the position of these triangles is the direction that this front is moving, and the same with the semicircles. It's sort of moving to the north, so we kind of see that. We also see that there are some general patterns here in terms of the air that we're going to see. Behind the cold front is where the cold air is. The cold front hasn't come through yet, so in front of it, it's warm because the warm front has come through. Remember that warm front's moving in this direction towards the north, so behind it, it's warm. All right, so we're going to pick up there in the next part. I'll make that part 2 of this, and we'll pick up there in a minute.